Hello?
Hello, are you hearing me?
Yeah, I can hear you. Can you hear me?
Yeah, I'm hearing you
Okay,
fine.
great.
Great. How are you?
I'm pretty good. I'm pretty good. I actually just found out that as a video interview, so
Yeah, okay.
yeah,
It's okay.
yeah. Is this your first time using this platform?
No, I'm used before, but from 2 or 3 months ago. So
Oh,
recently,
okay.
yeah. Are
Okay.
you?
I've used other ones, but this is my first time using this particular one.
Okay.
Yeah.
Yeah. Okay. Are you already software engineer or you seeking for a new opportunity?
I'm looking for new opportunity.
Yeah.
Yeah. What about you?
I'm working recently in Bloomberg, London office.
Oh, okay.
Yeah.
Wow. Okay. Yeah, I'm in Bay Area, California.
Okay.
Yeah.
Okay. Cool. Nice to meet you.
hmm
So it's supposed that I will start asking you first.
Okay.
So as you see, do you want some time to read the question first?
Yeah, let me see.
Okay.
So it's the BST successor search.
Yeah.
Okay. Okay, so in a binary search tree, an in-order successor of a node is defined as the node with the smallest key greater than the key of the input node. Given a node in
Yeah.
a binary search tree, you're asked to write a function, find in-order successor, that returns the in-order successor of input node. If input node
Exactly.
has no in-order successor, return null.
Yes. So
Okay.
what you need to do given a node, you have to get the smallest node which have a smallest value greater than the given one. If it
Okay.
exists, if it doesn't exist, just return null.
Okay.
And in the existing code, you have the struct for the node, which you will code in Java.
Yeah, I'm going to code in Java.
Okay. So in you have a class for node that contains the key and left and right, and you have access to the parent itself, and the constructor takes the value for the key, and for the method which you need to fill, which is find in order successors, take the input node and return a node, which is the target one, and null if it doesn't exist. And
hmm
you have some logic for the insert, but you don't need to take care about that. Okay.
I'm sorry, can you say that last part again?
You don't need to take care about the logic for the insert method,
The
which is this
logic
part.
for, oh, okay. The insert method.
Yeah, it doesn't matter for you.
Okay.
You will not need something like that. So all you need just editing, write your code here in this part
hmm
for this problem.
Okay. And then, so the input isn't the necessarily the root. It can be any
Yeah,
node in
it
the
could be
tree.
it could be any node, something like the tree example on the left. Okay,
Yeah.
if I given you something like 9,
hmm
okay, so I'm searching for the node which contains the element greater than 9 and at the same time is the smallest one, so it will be 11, right?
Oh, okay.
So am I expecting when I give you 9 as an input, you get me the node which is 11, this one.
Uh-huh.
Something different, if I gave you 14, you need to return the root which is 20
Okay.
because it's the first node greater than 14.
I see.
Okay.
So if I do have a 9, I want to return 11. If I
Yes.
if I have a 12, I want to return 14.
Yes.
Right. Okay. And I do have access to the parent nodes
Exactly. You have access to the
and link
parent.
there. Okay. So just yeah, going over a couple examples. Say you give me
Yeah.
11,
11. Yeah.
then the in order would be 12, right? Okay.
Exactly.
Okay. Mm, so I'm just trying to think of the different cases that we can have here.
Okay.
Um, um, so yeah, let's just say use 12 as an example. It would be four. So So if we're using 12 and we're going down the tree, it has to be on the right side.
Okay.
Um,
But think about it. If I give you 9,
and there's no 14 there. Right,
yeah,
yeah, if you give me 12 and there's no 14, then the answer would be 20, right?
if I give you 12,
Yeah, if you give me 12 and there's no 14,
yeah,
if that didn't
yeah,
exist, then I would have to go up.
exactly.
Yeah, I would have to go up and then I would have to check which side I'm coming from.
Yes,
And if I'm coming from the right side, then I would have to go up again.
yes.
And then that would be the answer. Okay. Yeah, it just seems like there's like a lot of different cases that we can have.
I think we have two cases, right? And you said it correctly. First case, which if I give you 9, I'm
Hmm.
expecting you to return 11, which seems that I will go down, right?
Right.
But in the other case, if I give you 12 without having 14,
Uh-huh.
I need to return 20, which I need to go up.
Right.
So think about it, when I need to go down and when I need to go
Yeah.
up.
So you have, yeah, I'll need to go down, case one, and then the other cases I'll need to go up.
Exactly.
Um, so
So
it's,
let's start with going down.
yeah.
When I need to go down,
Okay, yeah. If you need to go down, then you want to check if there's a right node. Um, check if uh, node.right exists.
okay.
If it does exist, then yeah, you want to go down and then go all the way to the left if it exists, right?
So think about it. If I give you 12
Yeah.
without having 14, this is the same, right? I give you a node
Uh-huh.
which doesn't have a right child, so you
Hmm.
need to go up, not down, right?
Right, right.
So if you don't have a right node, you need to switch to the second case, which is I will
Yeah.
need to go up.
So maybe I would do so. So the first case will be if right node exists, go down
Yes.
to the to the right. Oops.
Okay.
Go down
And now
to.
let us think about something else. If I give you 9,
Hmm.
right?
Yeah.
And you have a right node which is 12, which node you need to return? You need to return 11.
Right. Yeah. So you go down to the right, and then at this point check if left exists,
Mm-hmm.
and then if it does, I believe then you just want to go all the way. You want to keep going to the left until you get to a null node.
Okay, and if it doesn't exist,
If it doesn't exist,
which mean if I give you 9,
yeah,
you should return 12 without having 11, right?
right, right, yeah. So if it does, so because basically you're just you are still you're going to the right, and then you are still going to the left until nothing exists. So yeah, if there's no 11, then you would just if you had like a loop, it would just stop there.
Exactly.
Um,
Okay.
so it if it exists, go all the way left until null. And I think and then you should be done at that point for this
Sorry?
case. So I think once you do that, then you're done for
Yeah,
this
yeah,
case.
I think, yeah. In this case, yeah.
Okay. So then the other
So,
case when you need to go up,
yeah.
um,
So let's think about if I give you 12
yeah,
without having 14,
yeah, then you would have to go up.
yeah. Tell what?
You would have to go up, and then you'd have to go up again, right? You have to go up, and then you have to go up again until you get to 20.
Yes.
So when you're going up, I think you need to check which side you're coming up from.
Mm-hmm.
So if you're at 9, once you go up, you'll say if 9.right equals the node that we're on, then you go up again.
Mm-hmm.
But let's say we're on 14.
Yeah, I agree with you. If I
Yeah.
give you 14, so
Then
you will check that you don't have a right child, so you
right.
decide you will go up. So you will start with 12, and you are coming from the right.
Uh-huh.
So it seems that you need to continue, right?
Yeah, you need to continue.
So you will continue 10 till 9,
Right.
and you are coming from 12, which is from the right.
Right.
So it seems that you need also to continue, right?
Right. You need to go up
So
again.
you will go up to 20, and you are coming from left this time.
Then
So you need to stop and you need to return 20, right?
right. So okay, so in this case if you're coming from 11, you see there's no right node. So
Yes.
then you go up to 12.
Yeah.
You check that you came from the left, so you know you're
e-
done.
Exactly.
Okay, so let me write that down.
Okay.
So if you're not coming from the right, then you want to go to parent, uh, check which side you came from.
Exactly.
So if you came from left side, you want to return the parent.
Okay.
If you came from right side, um, go up again.
Okay.
And then you always have the case where if you are at a say you're at the root and there is no parent,
Okay.
then
It will be covered, right? Because if I give you 20, first check, well check if I have a right child, which is a 25, so I will return it, right? But if I don't have 25, I will go to the second check, which is I will try to get my parent,
yeah,
which I will find that I don't have any parent, so I can return 20 directly, right?
right. But
Or
I
return
think you
node.
would have to
You need to
check for
return
that.
node. Yeah. Yeah.
Right.
Sorry?
You'd have to do some kind of check to check if
I
parent
think
is
it will
null.
be included. It will be included in the check, which is you will do it here, right? Because this part you will do this part in while loop, right? And every
Right,
time you will check the parent. If the parent is null, so you need to stop right now.
right.
Let's do some coding.
Okay. So yeah, we're given the input node. We'll say if input node. So if input node, does not equal null, then maybe we'll do a recursive call
Mm-hmm.
where, again, we're just calling this on.
You will solve it in recursive. Okay.
Yeah. I mean, we could use pointers as well and just have them go up and down.
Yeah, you can just iterate, but okay, if you prefer recursive, just go ahead.
Yeah. Okay. So yeah, so if, like we said, if right exists, actually it might be easier to do it. Let's just,
Just
let's
okay.
just do this. So if input right does not equal null, we want to call
But
it.
you can you can't recursive on the same method because if the node to the right is exists, right, you need to use some different logic, which is you need to get the most left node, right? So you need to write a separate method which can, given a node, get the most left one, right? So I think you need to go here, right
Yeah.
here, and just type some method which is get most left, right? And you can give it a node which is call it x anything, okay? And this node is responsible for getting the most left child, right?
Right. So yeah, you'll just write if x dot left does
I
not
think you need, yeah,
if it
exactly.
equals null, then you'll just return x. Otherwise, get most left, x dot left.
But this check should be like that.
If x
And
well
here no,
no
you can't do that, because if you do it x, okay, let's assume that you will start with I give you 9, okay, so you will pass to this node the node 12, right? And you will start iterating. So the first time you will check is 12 dot left equal null? No, because it's equal 11, right? So you will go here and iterate again with 11. So and when you get to 11 dot left equal null, yeah, okay, cool, it's right, it's working, yeah, cool. So we will done with this method, right?
Yeah.
So here we need to do something like that, right?
Right. Okay. Yeah, that makes sense, because you're going to go to the right and then you're going to keep going to the left,
And here you need to
and then you'll
return,
return that. Right.
right?
Uh-huh.
Okay.
So I think
I
that
think,
covers the first case.
yeah, let's go to the second one.
Okay. So yeah, so we said we need to go up now. So we'll say, maybe we'll have another pointer.
It's a reference, okay.
Dot parent. So I guess, so right now we're kind of doing it the iterative way.
Yeah.
Okay. So yeah, let's just do it like that then, since.
Okay.
Okay. So if right does not equal null, we'll just go to the right and then go all the way to the left.
Yeah, I think we can call it in a more makes sense. So we have parent, right?
Yeah.
And we have here some node, we can call it child, which is the current node, right? Which is the input node right now. So we have child and we have parent. What we need to do, we are sure now we need to go up, right?
Right.
So we need to do it iterative way, which is we need to do some while loop or something like that. But you need to specify which condition you need to stop iterating, right?
Yeah.
What do you think?
So this condition is if parent dot left equals child, then you want to return parent, or then you want to return, yeah, parent.
So what we need to do now, we need to reverse this condition and put it inside while loop, right?
Yeah. Because if the parent, because if this isn't true, then
I need to go up, right?
we need to go up again.
Exactly. So if we change this one to be while, and we do something like that, right? I'm just reversing what you said.
Yeah. Then you
So
go.
if I'm not going from the left, so I need to go up, right?
You go parent equals.
So we can just remove this part, and instead of left, we can do it a right, exactly.
Yeah. While it equals right, then parent equals parent dot parent.
Exactly. And for the child, you need to set it first, right?
And then yeah. Child equals parent.
Exactly. And you need to just cover one extra check, which you mentioned before.
Yeah, if
which
it equals,
become the root
if it
itself.
doesn't exist, yeah.
Right.
So we'll say, maybe, let me think where we need to put it for a sec.
Okay.
Yeah, I think we could just put it here. If parent dot parent equals null, then we're just returning null.
Think about the position for the condition again. If I give you, let us make some debugging, okay?
Yeah.
If I give you 9, so here the parent will be 20, right?
The parent will be 20.
Yeah. And the child will be 9. I will check if the parent dot right, which is 12, which is 20 dot right,
25.
equal child. No. So I will go inside this for loop, parent dot parent equal null, right? because the parent for 20 is null, right?
So yeah, while parent.write, yeah, wait, so
Parent dot write equal child.
parent is 20. Yeah, parent.write, it doesn't equal child,
Yeah. Ah, okay, that makes sense.
right? So hold on. So while parent.write equals child. Sorry, someone's at the door, I think.
Take your time. Take your
Yeah.
time.
So yeah, so input, so parent is 20, child is 9.
Yeah, we
So
can't. Okay. We can't make debugging for this one. Let me do it again. If
yeah,
we change 9 with 14 and the parent now with 12, okay? So we'll start from here. Is parent dot write, which is 12 dot write equal 14.
excuse me. Actually, can you give me 1 second? Someone's at the door. Like
Okay, take your
literally
time.
one
No, no,
minute.
okay, take
Sorry
your
about
time.
that.
Okay,
All right. Sorry about
okay.
that.
No, 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 it's
Okay.
okay, man. So the parent now is 12, okay?
Yeah.
And the child is 14, okay?
Why is it for? Oh, so yeah, okay, yeah. It's child 14, parent is
Yeah,
12.
and the parent's valid. So I'm expecting from you to return 20 for me, okay?
Mm-hmm.
That's what I'm expecting. So we will start debugging. The parent dot write, which is 12 dot write equal child equal 14. Yes, that's true.
True.
So I will come here.
Mm-hmm.
If parent dot parent equal null, no, because it's equal to 9. So
Yeah.
I will continue. The child will be 12,
12.
and now the parent will be 9, right?
Right.
I will continue again. If 9 dot write equal child, yes, that's true. So I will come here. If parent dot parent, which is 20 equal null, no. So I
Mm-hmm.
will continue. The child will be 9
Yeah.
exactly, and the parent will be 20,
Parent will be
right?
20. Yeah.
Then I will come back. If the parent dot write, which is 25 equal child, which is 9, no. So I will come here and I will return the parent, right?
Right.
So that's working,
Yeah.
but I think there is some case it can be not working. Let me think
Okay.
how we can break that. Um, so
Do you see a particular case that wouldn't work?
yeah, I see a one. If I give you the input node, it's already null, okay?
Okay.
Which is I gave you already a null input, not an invalid input, okay?
What do you mean? Like a node that's not in the tree?
No, no, no. The node is null. Itself is null. It's not an invalid input, right?
Yeah.
So if you will do it here, which is null dot write, it will be through an exception, right?
Yeah. Could we just do a
So
check at the
yeah,
beginning?
exactly.
Okay.
So at the beginning, we need to check if the input node not equal null or equal null. We just need
Yeah.
to return anything, right?
We'll just
Which is
return
return
null,
null.
right?
Exactly. And I'm thinking about different case. What if
I think this should
yeah, I
cover
think
all the cases.
yeah, yeah. I think
Um,
yeah, it's working fine.
yeah.
But let me think about if we can break it.
Okay. Yeah. Let me think. 5.
Yeah, I think it will work. Okay, what is the time complexity for this code?
So the time complexity. I think it should be log of n.
Okay. Why log
Yeah.
of n?
Um, well, just from looking at it, I know when we're going up the tree, we're
Mm-hmm.
only looking at the nodes that are on that particular path. And
Okay.
like if we want to trace it the other way around, we know that we're only checking half of the tree each time.
And what is the height of the tree?
Um, hmm. Well, I guess if the height of the tree is n, say we just have like one, no, say it just goes one way and everyone only has like a right or a left,
Yeah, exactly.
then you would be looking at
So,
every
so
single
yeah,
node.
so in the best case scenario, the height for the binary search tree is log n, right? Because
Right,
it's a binary search tree.
right.
But in the worst case scenario, which is we only have nodes in a only one way, which is only right, only left, we can
Mm,
have a chain, which is called a chain problem, and it will
mm,
be a linear, right?
right.
So the time complexity in the worst case scenario will be order n, but in amortized block time
Hmm.
or the average running time, it will be order log n, as you mentioned. And
Right.
what's the base complexity?
The space complexity will be since we're not calling it recursively, it just should just be constant space.
Yeah, cool. I agree with you. Cool.
Yeah.
You're done, man.
Well, actually, when we're doing get most left,
Yeah,
then if we have, like you said, only if everything is to the left, then that would be
yeah, I
calling
agree
it.
with you. But in the worst case scenario, you will not iterating through all of the nodes because you will to get this point,
Hmm.
you need to have at least one right node, right?
Um, yes. Okay. Yeah.
So
So if you
yeah,
have one
okay.
right and then
Yeah,
all
you can
left,
exactly.
yeah,
So it will
there.
be order n minus one, you know.
Yeah.
You
Yeah.
can discuss that with the interviewer. Both of them are valid.
Yeah.
But I think for me, constant will be a satisfied answer, and this is what I have in my model
Yeah.
answer.
And we could
But yeah,
also we could write get most left as the iterative approach where we just use a pointer, and then it would be no space.
but you can't do that because if you want to do that, you need extra space. You need because you need to keep track with the most left node, right?
Um, yeah, I mean you would have the extra, you'd have the pointer, so
So yeah, just you need extra memory inside each node because you want each node to point to the most left node in the same path. But you can't do that, man,
okay.
because you will break another thing. If you want to keep a pointer inside the node itself,
Mm-hmm.
which can point to the most left node inside the same path, every time you insert a new node in the binary search tree, you need to go in the full path and update all of them again, right? So let me think. If we back to the
Well,
same question here in 12,
well, I'm just thinking in line 70 on this function here, can't we just have a pointer that just goes all the way to the left until we hit a node?
yeah, that's a problem because if you insert a new node, which will change the some order for some of the node, you need to reorder the same, right? You need to reorder this pointer in all the node, right? And that will break the conditions that we can insert in the binary search tree in log time, right?
Mm-hmm.
So it will violate another conditions, but
Okay.
okay, cool.
All right. Is there any way we can run it, or are we just gonna? There's no
You
test
can,
cases, are there?
I think I can run it. It's running now.
Okay.
Um, you have some
So there's
missing
no.
return item in 77. Let me check that. 77. Wow, what is that? Oh, okay. So if we reach this
So we should
point,
just get rid of the else
yeah,
state, or we
we
could
need
just
to
get rid of the
return.
else. Yeah,
Okay,
I think that could.
can return. And so you have expecting a line 73. What we have.
I don't. What do I see? So error, not a statement.
No, that's the E. Where is the E? I don't find the E.
Yeah, I don't know. Maybe let's try it again. Maybe we were both typing and maybe it got messed up.
Okay. Yeah, it's
Okay.
running now and it's working. Right.
Okay. Cool.
Cool.